subject to regulations by the European Union that says we have to have clean groundwater by 2015. But unfortunately for us, it takes a little while for solutes such as nutrients to be transported from the top of the soil down to the groundwater. And to make things more complicated, Irish soils are like a patchwork quilt. They don't match. What you have here in Galway is nothing like what I have down in Wexford. So we can't say what is the delay, or as we call it, time lag, across the board. It's site specific. And we need to calculate this so we can manage the expectations of the European Union. So I've been estimating the travel time or time lag using software called Hydrus 1D. And what Hydrus does, it simulates water movement through the profile. And I've said the accuracy of the simulations depend upon the data you feed into the model. So it depends on how well you can describe the soil. So what if you use a very simple description, your textural class, it's how the soil feels basically. And it gave me one estimate of time lag. I said, well, what if you actually measure the size of the soil particles? That's our particle size distribution. And as you can see clearly, the estimate of time lag changed. This is very interesting. So I said, what if you really looked at the actual structure of the soil? And this is done using something called the water retention curve. And sure enough, it gave us a different estimate of time lag. Now, based upon our knowledge of the soils, we were able to say that this one is probably the best informed, probably the most accurate estimate. All great. Here's the problem. You use these devices called pressure plates, and they take forever. I had samples that I put in March, and they're still running. I still don't know what the time lag is for that site. So we need a better laboratory method. So what I did was I put the soil in a centrifuge, and I spin it around very fast, and it causes the water to be sucked from the soil at pressures many times gravity. And this allows me to form, the soil water retention curve I showed you earlier. It's a much better method. It's faster, there's less elements that can go wrong, so there's better accuracy. And best of all, anyone can do it, because I can guarantee you, any lab worth its salt in Ireland has one of these centrifuge devices, where there's probably maybe 4 or 5 labs in total which have these. They're very expensive, they're bulky, they're complete pain. So we're trying to encourage people to move towards the centrifuge method. And the final stages of my PhD, well, the next 2 years, and it's not final stages, it's a long way yet, I will be further refining my centrifuge method and developing better boxes basically to put in the centrifuge. I'll be working on fine-tuning my estimates using Hydrus 1D, and then I'll be putting a tracer study in the field where I'll apply a dye at the soil surface and visually map it move through the soil. And that will allow me to say definitively which estimate is the most accurate. So thank you very much, and I hope you're interested.